Good afternoon. How's everybody today? We are back. We're going to do some more NIFs today in Rust. I think that where we left it off last time was really pretty good. It felt good to have done all that code and then finally be able to test it with anything more than just an interactive shell session. So that was good. Having real tests around it makes it feel more real. And there are a couple things I want to do today, and we will get started in just a few minutes. So let people trickle in. Thanks if you're already here. Say hi if you want, and we'll get going on the code. So it's a little dark today. It's rainy here in Kansas City. Been overcast all day, so I do have the brightness up a little bit, and I actually think that that's going to be too bright. Yep, that'll be fine. It will get a little bit. Hello, Frosty Crunch. Welcome to the stream. It will get a little bright when I'm looking at certain web pages, but we'll make do. Okay, so I'm gonna switch to the other screen. Excuse me. All right, and hopefully everybody can see that. Okay. Okay, so what do we have so far in our tree setter bindings for Elixir? We can parse things. We can execute queries. We have kind of a very basic node API. It's really just exposing nodes in the tree, in the parse tree, as data rather than as actual stateful objects that you can poke at. Hello, Tuxified. Welcome. Love that emoji. And then we last time we wrote a pre-order iterator. So basically going from top down, the left side of the tree through. We might consider making another kind of iterator, maybe a post order. And I had this discussion offline, or at least off stream, with Mitch, who was the original inspiration for this project. Yeah, there's no such thing as an in order iterator for a tree with arbitrary cardinality. So we won't be making an in order iterator. That doesn't make any sense. But today, what I'd like to focus on is doing tree edits. So, and I have the documentation up here. Let's see. Yeah, so you can, let's see, go to editing. You can tell the tree that you're going to make an edit to it. And then call parse. I'm going to see if I understand this right. But you call parse on the parser. You pass it the old tree, which previously we didn't allow to be passed, right? You can pass the old tree, then it can reuse the nodes in that tree. It's a bit more memory efficient, and will you can reparse the document. So that the nice thing about that, aside from the memory efficiency, is that if you have the identifiers for each node, those identifiers don't change for the nodes that don't change between edits. So that's also really good if you're trying to track some things that might be like important points in the program, in the document that you're parsing, and you want to be able to refer to that by consistent ID. That's really good. So we're going to try to do editing. So they're saying here, first you must edit the syntax tree, which adjusts the ranges of nodes so that they stay in sync with the code. So this is saying, here's how the changes, here's how it has changed. And it's interesting to me that the start byte and the start point, maybe that lets you slice off parts on the front. I'm not sure. And so you're basically saying, here's where the new tree starts. And and then you do the old end and new end. So I think it's probably trying to, excuse me, it's getting warm. It's probably trying to make makes the right amount of space, and to also know which nodes to retain. Yes, that's the point, Tuxified. It looks like you can tell it which range changed, so it doesn't reparse the whole document. Exactly. Yes. And that's one of the neat things about Tree Sitter is that it allows incomplete trees. And we saw that last time we were looking at the nodes which are error or have errors in it. You can continue parsing, even if you have errors in the document. So like if it's not an actual valid syntax tree. It's one of the advantages of Tree Sitter, makes it good for editors, but also might be useful for compilers if you want to do that. Anyway, and then the next thing I wanted to look at was multi-language documents. So the quintessential use case is embedded templates like EJS or ERB. We have EEX. I don't know that I'm going to tackle HEEX in this one, but we might be able to do something like this. Obviously, this is Ruby, not Elixir, but we could do like Elixir things between or inside the template tags, and parse the rest as HTML, and that could use the embedded template language. So yeah, so here. What they're doing in this example, and this is C, unfortunately we have to translate some things to Rust, but you get the embedded template and HTML language and the Ruby language, and you kind of compose those together, so you get trees that are kind of overlapping. And let's see what they do here, and then we'll go and we'll start working on tree edits. I'm going to pop my gum in here. Okay, so you parse the embedded template language first. And then you go, let's see here. So it looks like they've kind of like statically allocated some arrays of range objects. Okay, and then they're going to, let's see here. Okay, so they're going through all the children of the ERB root node. And I'm guessing what happens here is, looking at this example, it doesn't look at the structure of the two languages that are embedded in it. It only looks at what are template tags and what are not. So you get a flat list, if I had to guess. So that would be like the first node would be an HTML node, and then you would get a template node, and then you get an HTML node. And these are like, it's not, or maybe there's only like template nodes and non-template nodes. Okay, so they're saying here, if it's content, right, then you add the range for HTML. And if it's not content, so if it's template, then you get the first child node, name child, of this non-content node, and then you get its range and you add it there. And then, okay, and so here's the big thing that we'll have to add, in addition to maybe something like this. Although we could use our pre-walk probably to get this information. And then you create a parser, or maybe you use the existing parser. Is that what they're doing? Yeah, they're reusing the parser. I don't know that I would do that. We'll have to think about that. Okay, so then they're using the parser to parse the HTML part, and then you're calling this set included ranges, and you're giving it the list of ranges, and obviously it's C, so it doesn't know how long. It doesn't have formal slices, so this is just a pointer to that array, and this is how many. And then and then you're getting a tree back. So you passing the text again. Okay. Cool. And then you get the root node of the tree. So yeah, and then you can do the same with the embedded language. So in this case, they're using Ruby, and then we can. So they're reusing the parser. We set included ranges on it, given the ranges that were inside those template nodes. And then you parse it again, and you can get out the root nodes. Okay, and then what they're doing here is they're printing the syntax tree as an S expression. So yep, and that's it. Now, interestingly, maybe we'll come back to this at a later date. You can copy trees very cheaply. I'm guessing they have some kind of internal reference count type thing. Yeah, atomic reference count. So yeah, so you can query, edit, reparse, or delete on a new thread while continuing to use the original tree on a different thread. Okay. That's cool. We may make use of that. I'm not sure exactly how yet, but let's get into it. Let's go back up here and look at edits, and we'll see if we can't make some headway on that. Okay, so we were building out the high-level API last time. We might, if we have time, start to fill out the doc strings and things for this. Okay, so those are the base ones. Let's see. And then we had some additional structs inside query. And I think we'll just do this at the top level. I don't see a reason why not. But what we need to do is define this struct, and then we will also define it in the Rust code with that same kind of encoder stuff that we did before. So, okay, so we need to do def module tree sitter, and this is input edit. And I've been doing Rust in my day job. I opened curly braces instead of do end. Okay, so then we need to def struct this. Def struct. And we'll just, we'll do it as we did these others. Start byte, old end byte, new end byte, start point, old endpoint, and new endpoint. And that should probably wrap. Yep, there it goes. So now we have the ability to pass this across the NIF interface. But in order to make that actually true, we need to go in here and let's see, I think it's in here. No, we just did it in lib, didn't we? Nope. Okay. Where did we define those structs? Were they in query? Yeah, I think at this point we need to start reorganizing some of this stuff, because these are not necessarily query related. I think we moved the Elixir side. Yeah, let's go ahead and make I'm gonna make mod document. I don't know that makes sense, but we'll make a new one. And let's see. And then let's see if there's a code assist for this. No. Let's go to the top. Okay. Just say use create document star. And then we can just move those things. We'll leave the query related things in here, the captures and so forth. And then we're going to take node and range and point, and we'll move them over to this module. And this is, not strictly necessary, but it feels weird for that to be in the module about queries. So, oh yeah, and I don't have Rust Analyzer working, so I'm going to have to guess on this. Let's look at what the imports are at the top. Yep. Okay. And that's a bit big. Oh yeah, and I forgot, I didn't make my text smaller so we can get more on the screen. Let's do that. That should make it a little bit more readable. Okay, mix compile. Okay, so yeah, we didn't use error. And okay, so that's a direct reference. And it's warning about dead code. I don't think that's true because, oh, we just didn't save query, right? That's probably the problem. All right. Struct import node is private. Yeah, so we need to fix that. Parser. All right, let's do query. No, not project search. There we go. Query node, and let's replace it with document node. Okay. I'm going to full screen this because we're getting errors in here that... Okay. And then in parser, we need to fix it there. Create document node. Okay. And maybe we'll do star. That way, if we add, for example, if we add that input edit struct, which we were coming in here to do, then it'll automatically be added there. Although we may put it in here. I'm not sure yet, because it is related to parsing more than it is to the document itself. But let's see what we got. Right. Okay. Okay. So we fixed the compilation errors at least. All right. Let's go ahead and make an input edit. This is derive NIF struct, right? Module is tree sitter dot input edit. Struct input edit. And here we are again copying those fields. So let me split left and we'll hide that. Okay, start byte. I think that this is maybe a case where I need to look at the Rust crate documentation so that I get compatible types there, because we're honestly just going to copy. Let's see, input edit. Right, usize and then points. Okay, that makes sense. old end byte, eSize. And I would really rather not do this sort of copy thing, but we'll do, you know, from each direction for these things, and it'll be straightforward. And if we're lucky, the compiler will make it pretty efficient. Old endpoint, new endpoint. Okay, so let's impl from. And it's not going to do it for me. One thing I've been thinking about is while we're doing this, we could open Z with inside that native directory, and then we would get Rust Analyzer for the native code for the NIF. But maybe we'll try that in a little bit. I mostly just need to do some typing right now, so we'll get, and maybe I want to destructure this. Let's just do it brute force. There's not really a point. And it'll keep with the pattern that we have above. And then for each of these, because these are our structs that we're turning them into, not tree sitter points, we need to use the implementation above the from, right? If I were really concerned about efficiency here, I would probably do, you know, unsafe transmute, but I don't really think it's necessary yet. We haven't proven that it's actually a bottleneck, so not worth it. And there's a high likelihood that the compiler will go, hey, these things are really similar memory wise, and we'll optimize that for us. Okay. Now we need to do the other direction, which is probably the more important one. Here, I'm just trying to go, you know, for completeness, we have all these other things. And we will need to basically do this, but reverse it. And luckily, I think this, you know, this will be basically what this one looks like as well. So let's just copy pasta that. And we'll use our input edit for tree sitter input edit. And then there's no code to change there because, you know, this switches as well, the point, sorry. And I think that we might want to also do it here. I'm not sure that we'll use it yet, but yep. And then we have it go in both directions. So if we need to convert, we can do that really easily. Okay, so let's compile this jazz and see what we got. Okay, we've got problems. Well, helps if I read. I think I might have been looking at the C code. Yeah, let's rename those to positions so they're consistent. And we can, nope. Let's say end point, and we're going to replace it with end position. Okay. And then we need to do it here too. And this will be easier to edit. Position. Oh, and I think that these were start position. Yes. So we'll change that. And let's just do rename symbol. Well, it's not going to work. Position. And this is position. Hello, Bianca. My cat is about to try to walk across my keyboard. Okay. I'm going to remove that split. We're in a good position. Haha. Okay, let's see about our compilation. Okay. So I missed a spot. Yep. And it's right here. Okay. All right. So now that we've got that boilerplate out of the way, we can go in here and right. So then right. So this is a case where you're passing no parse tree. And I think that we probably want to make a function here like reparse. And then we have we've got locks. Yeah, because this is going to come in as a resource, right? So yeah, let's say this is old tree, and that's a tree, and maybe because it's going to be come in as a resource arc, we want to borrow it, and then we'll say new text, and we'll do this, you know, as ref u8 again, and this will return option tree. So this will be what we use to, after the edits have been done, to generate a new syntax tree from the updated document. Okay. Okay, so we're gonna have to lock and I think that we want to do this okay later. So what we're doing here is this lock returns a result, and this okay turned it into an option because we were letting it throw away what the error message was. But because we're about to do another lock, we want to yeah. So remember, this lock is around the tree sitter parser. The thing here that sucks, for lack of a better word, is that there's some mutex inside here too. And I would rather not have that mutex, but we get to. because otherwise it's not safe to put inside a resource arc, unfortunately. Okay, so this is a result, and if we're able to lock that, then we need to let's look at the docs. I don't have it in my brain. We need a way to like zip the results together, basically. Yeah, because I was going to do and then. Now we could do and. Except that returns the result of the latter one. And maybe what we want to do... Yeah. Okay, so we'll use and then. And this is... Hi, Sam. Welcome. Okay, so if we locked it, then we want to do old tree dot lock map, and here's where we're going to take the second lock. I wish we didn't have to do this, but here's the old tree, and we're going to say the P here and the tree. So what we've done is we've taken the result here and the result here, and we've basically zipped them, right? Okay. That is not my favorite. Okay, so, and then we'll say okay. And here's where it gets fun. Okay, so now we have a parser and a tree. And I should maybe make these a bit more obvious. And this will be, let's go ahead and shadow that, because will you reformat for me, please? No, you won't. Okay, I'm just going to start putting line breaks in here. Okay. And now we've got the parser in the old tree. That's why I wouldn't. Fine. Okay, and so then we're going to do parser. Let's look over here. And it's parse, right? So we pass some of the old tree. Parse. And it takes the new text and then some of the old tree. And then we can map. Interestingly, I think this is an and then as well, because the parse returns an option as well, and then we map tree new. And I'm not sure that this is going to work. Hey, it's formatting for me finally. But let's go through this again. So what we're trying to do here is to reuse the old tree after we've done an input edit. We'll get to the input edit here in a moment. So we have the parser, we have the old tree, and we have the new document text. So we have to lock the inner parser inside our parser struct. And then we also have to lock the old tree. Unfortunately, I don't... Erlang. We have to have mutexes. Okay, and then we turn that, so this okay turns that result into an option. So if we lock both of them, we get an option containing the parser the inner parser and the inner old tree. If that is okay, if that is some, not none, then we call parser parse, and we pass it the old tree and the new text. That will return, because this is and then, that will return an option. And then we'll map over that option, creating our tree from the tree sitter tree that was returned. Okay, so feels a little bit like pipes on Elixir, but it's method chains instead. Okay, so well, let's see what the compiler complains about now. Okay, so that's interesting. It says rapid and okay. That doesn't make sense to me. Because lock here is returning a result. Right? And map will not change whether that's inside an okay or an error. Right? Okay, let's read this in more detail. Okay, expected a result of something and poison error. Found result of tuple and doesn't know. Or rather, this just, the type got too deep there and it elided it. Okay, so it found a result of, expected a result of anything, and then poison error mutex guard tree sitter parser. And is it because okay, I think we probably need to remove method chaining here and let the auto conversions work. So let's say parser is self.0, and I'm not certain about this, but let's say old tree equals old tree dot lock dot okay. And what we're doing here is we're swallowing that error. We're not trying to conflate the two. And these will become early returns that return none, right? We can't lock it. And then we can say this map tree new, and we can get rid of this. Probably a little bit easier to read too. My only concern there was going to be at times when you take things that are essentially mutable, they are mutable, and you get overlaps and it gets unhappy. But like, honestly, that's easier to read. Maybe we'll just go with that. Okay, so that does need to be mutable, right? And I don't think that the old tree needs to be. Right, never used, fine. Don't care about that. We'll use it in a moment. Okay, so at least it's not complaining about anything inside our function. That does read better, doesn't it? Should we rewrite this one to look like that? Let's do it. And then there'll be some more similarity here. I know. It's not like pipes anymore. And then it's more similar. Now, one thing that we could do potentially is just make this function take option of the old tree. But I think we'll want to distinguish the interface level functions. Yeah. Oh, that's a good point, Sam. Maybe I was missing, because remember we just changed this and it had mute in the pattern match of the closure. Yeah, if you're going to write an imperative language, writing multiple statements is a nice way to do so. Absolutely. Also, just I think that it cuts down on the noise. Here, so we're separating the locks, taking the locks from actually performing the operation. And yeah, and I mean, if we wanted to be really pedantic, we could go like match on this, or if let sum or something. But there's not much there. Okay. So let's go back up and write a NIF function. So we're going to do schedule dirty CPU again, because why not? Not really knowing the expense of these is a part of the problem. Okay, so we have, this was going to take a parser, and remember here, like at the interface level, we're using these resource arcs. This is going to take the old tree, which is also going to be a resource arc of the tree. And it's going to take the text, which is going to be binary. And it's going to return basically the same thing here. Okay, and then we say parser, reparse, text as slice, and then we'll borrow old tree. I'm sorry, it takes the tree first, doesn't it? Yep. Old tree, and we'll map resource arc new. And let's see what we broke. I missed an opening brace somewhere. Or a closing brace. There it is. There's the error. Okay. What am I doing? I messed that up. I used P. Yep, this needs to be parser. So refactor that method and didn't fix it. Okay, and then last step, we add this here, right? Okay, time to get rid of the gum. All right, so now we need to go up to our Elixir code, and we need to make this. And this is basically reparse as a parser and old tree. Okay. And I think, did we just added it down here? Right. Okay. So now we can do the second step of this process. But we need to be able to do the first, which is to signal to the tree that it was going to be edited, right? Which is over here. You call tree edit. And it takes a tree and then the input edit, which we created that struct for. And we're not exposing nodes, so we don't need to worry about the node edit. Right. Okay. So let's go ahead and make tree edit as a NIF function. Then we'll go backwards. I know we've done a lot of bottom up, but let's go backwards this time. And I think that this might not need dirty CPU, but we're doing everything on that, with the exception of some of the language things, because we know that they'll have reasonable bounds. I don't actually know what tree edit does internally, so source arc parser tree, and this is going to take document input edit. I think that's where we put it, and returns nothing. So we're going to say tree edit, and this is the edit. Okay, and that will not compile because we haven't added this method yet. Let's put it down here. Edit, and this is going to take self and edits. This is be document input edit. Did we? I think we imported all of that module earlier. Input edit. Okay. So let's say let tree lock. Okay. We're unwrapping in the other code. It's fine. And we don't technically need that self zero because we have deref on it. Okay, so we get the inner tree. And let's look at the Rust documentation for this. Make sure we get the right function here. And we call edit. Okay. This is probably not strictly necessary. And let's not do it. Tree edit, and this takes mute self, so we need to have mute here on the match, right? And we'll say borrow edit dot into. Okay. Let's compile that. Okay, so now it's complaining I don't have that defined in the module, which is what I would expect. So let's do that. Go in the NIF. Def tree edit. And it takes a tree and an input edit. And then we do NIF error. When you're making a version of edit, take a mute tree. If I'm understanding you correctly, this, you're saying mute self. Well, because we would need to, at the interface layer, this is not here. This is a resource arc. So we would have to, like, you can't take a mutable version of this. We have to do it inside here. Yeah, because this tree contains a mutex over the tree sitter tree. I know it's like a pain. Yeah, and I mean all of that, like, I would rather not use mutexes here, but all that is because we don't know what thread this this resource is going to come back on when the NIF is called. It could be a different scheduler thread than the one that we were on. And also we're doing on dirty CPU threads as well. So we're actually, we're not even on a scheduler thread at that point. We're on a different thread. Okay. Right. So the resource arc, Sam says, so the resource arc means you have to forgo the static checking that mute self enforces and instead do it dynamically with a lock. Yes. And if we were doing something more clever, we might not wrap these in resources and use our own internal indexing or something. I would rather not do that because I think that introduces potential confusion. And also I think it might be hard with the API that Rustler gives us. It really wants you to use those resource arcs, which means you need to have a read-write lock or a mutex down inside. I might be able to get away with a ref cell, but I can't necessarily guarantee that you don't pass these resources across different processes. So ref cell would be just asking for trouble, I think, and in fact the compiler might not even allow it. So I think that mutex is probably the way to go. And I mean, this is basically like what you would do in a multi-threaded Rust app that isn't like focused on async. Everything would be like arc mutex that needs to be mutable across different threads, right? So arc for the cheap copying and thread safety, and then mutex for making sure that you don't hold it mutably across multiple threads. Okay. This is a good question, Sam. Thank you. Okay, so now we've got the NIF functions. So let's make edit here. And this is going to take basically this stuff. Again, we don't necessarily need the language, I think. Yeah, but we're going to make a new tree, right? And this is the input, and let's pattern match on it. Okay, that was long. But I defined it. What are you talking about? Probably needs to recompile. Okay, let's just assume it's wrong right now. Okay, so now we need to call, we'll say new tree. Is treesitter.nif.tree edit. And actually this is not create a new tree. It's the parser reparse that creates a new tree. So we don't actually need to return anything here. We'll just return nil. Although I think it will already return nil, right? Edit. So that can be a very bare function. I still don't know why it can't find that. Input edit struct. I ran into this before. Last time, in fact. Let's say when is struct edit tree sitter dot input edit. Is that the arguments? It's showing the documents for isstruct2, but it's showing isstruct1. Cool. Isstruct. Okay, so yeah, so that's the name. Yeah, and that's probably, that'll break the cycle there. I don't know why there is a cycle. Like the input edit struct doesn't refer to anything related to the tree. Weird. Okay, so now we've signaled the edits. We need to go back to the parser, and we'll say reparse. And this is going to take our parser, and we're going to need all that. And yeah, because we ran into this here, remember? Like, this was defined before tree, though the order should not matter. Maybe it's because they're in the same file. Who knows? Okay, and then we're going to take the old tree, and I don't think that we need the language or the source because we're passing the new source, right? So we're going to take the old tree, and we're going to take the new source. And I think that this is probably going to do the same thing. Yeah. Fine. And then we'll do when isstruct tree sitter dot tree. I don't know if something has changed in recent versions of Elixir, but that is troubling to me because you used to be able to do this. I'm not sure what's going on there. Okay. Yeah, it's unused. Fine. Okay. So what we're going to do, and I think one thing that we maybe did wrong, let's look at our, on parser parse, okay, returns option. It's interesting that here it can return error. Okay, so let's do case tree sitter dot nif dot parser reparse, and this is going to take the parser, and it's going to take the old tree, and the new source. Okay, so we'll say tree.tree because that's the inner part in that struct, like so, and we're going to take the source. And if it's going to be error, we'll return that. Else, if it's a new tree, then we need to do okay. And we'll do this goop again because the compiler doesn't like me. And it's going to take the tree. It's going to take the language. So we parsed out the language there, right? And it's going to take the source that we just passed. Okay. So we're probably at the point we need to write a test for this, and then we'll make a commit because I think this is important to do. And let's make a really, really simple test. The interesting thing here is I'm not exactly sure Okay. Yeah, I think that this will be interesting to write a good test for that doesn't just break. Okay, so let's do test accepts tree edits and reparses. Okay, so we're going to do some of this stuff, right? So we know that this works so far. And there's not really much in here. We're going to need to compute some things. So let me do this. Let old text, and then we will, so we're going to have to do some metrics on that, or at least be able to reason about it. Okay. So now we're going to, wait, what am I doing? Wrong language. Y'all need to call me out on that. Okay, so old text. So we're going to make an edit to it. And I think what we'll do is we will put a comment in the beginning and a line return. So we'll say new text. And we'll take this and we'll go comment. Okay. And then our edit is going to be and we need, this is not Rust. So let's split down and I'll get the input edit. Okay. If I understand this correctly, we say start byte is going to be 0 still. Old end byte, we're looking at this as, we can say that's old text. I think it's string length. String length, yep. Actually, we can do byte size. That might be off by 1. We'll see if we panic. New end byte is byte size of new text, right? And then start position is going to be point. And what does the point take? It's a row column. Okay. So row 0, column 0. And then we've got old end position. And this should be pretty straightforward. So we know in the old one, it would be row 1 if we're 0 indexed, right? Row 1, column 1, 2, 3, 4. Does that make sense? Row 1, column 4. I should also double check that tree sitter uses 0 indexed rows and columns. If it doesn't, then we have a problem. So the new end position is going to be the same column because we didn't change the trailing line, right? But it's going to be row 2 because we added a line. Okay. Let's see if we can find in the documentation whether it returns row and column. Isn't the edit just the comment line? Yes. But let's look at this. So it's an interesting question, Sam, whether this start byte, you're thinking about the start byte and start point, whether those refer to the old tree or to refer to the new tree. That's a really good question. There's some things missing here in terms of understanding. Like these are examples of how to do it, but they're not saying. I know what we can do. So we can do. Let's remove the split here. For example, here we can do io.inspect root node, and then see what that looks like. Because if it's 0 indexed on the data that we pulled out of it, then we'll easily know that. So let's make sure we don't run that. Let's run mixed test. Tree sitter test and line. Oops. Nope. Line 39, I think it was. 39. Right? And let's compile all the goop. Okay, yeah, so it is using 0 indexed. Like, so that question we've got answered. Yeah, I'm not certain either. That's a good question, Sam. He says, isn't the edit just the comment line? Maybe, really not certain. Those positions refer to the span of the comment line you added rather than of the whole new source, but I'm not sure. Yeah, I'm not sure either. And I wish that they were a little bit more explicit about that. Maybe we can find an example. Note there you can do edits for individual nodes as well. Oh, okay, good point. So Sam says, I think the relevant values would be start byte 0, right? This would be the edit that was made. Old end byte would be 0 because it was before what was there previously, and then the new end byte would be the length of the edit, right? Let's see if we can get some more details here. Yeah, the runtime. Ha 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 ha. Let's look at the code. I think that we need to look at the maybe see if there's some examples in the repository here. I'm not seeing examples. Is there a script? Is a benchmark script? Nope. Not interesting. Okay. Nope. That's interesting. Okay. I didn't know about that. That's not what we want though. When you look at the test, not profile. Let's look at fixtures, grammars, nothing in there because it's generated, error corpus. That's not helpful. Test grammars. Nothing about the exercising edits here, is there? Fuzz. Oh boy. Those query cursors. Yeah, that doesn't look like what we need. Profile. Okay, so that's a profiling script. CLI. That's just about generating parsers. Okay. Let's see here. Really not seeing any examples, which is kind of frustrating. Let's see if they have anything in their wiki. Useful external resources. No. Not very useful. Okay. I think we might be out of luck and we're just going to have to try this and see what happens. And I think that here we can remove this. And let's do, so we made our edit here. Let's go ahead and call and pass our edit. Parser, reparse, and we're going to say we need to do assert okay, new tree. Reparse takes the parser and the tree and the new text. And then I think we want to do something like that, like just print out the node walk, because I have a suspicion if we do this wrong, this is going to panic or something, or it's going to return no tree, which is not all that useful. But that interface in the Rust code, this doesn't return anything. And then the parser parse just returns none if anything goes wrong. But those are only 3 cases, it looks like. But since old tree is great, you must edit old tree to match the existing new text. But it doesn't say what these actually mean. A summary of a change to a text document. Right, so what do they mean? Okay. We're just going to have to try. And if it does, then let's do ioinspect tree pre-walk new tree. And we'll just get out the nodes. I think that's how we call it. Yep. Just get the list of nodes. Okay. Let's watch it blow up. Oh, okay. It didn't. So let's make sure that these nodes make sense based on our new tree. Right, so maybe our edits didn't make sense. Probably what we should do is do a before and after. Um, so let's do and say label before. And we will do label after. Because what I want to see is if some of those IDs match up. If it is, and honestly, I made a mistake here. These are like 3, because there's no trailing line return or anything. So we can fix that. It looked like it was robust, robust to that error of ours. Okay, so let's run just this test, line 59. Okay, so go up to the top. So before, so for example, here's an ID that is this is the source, so that's like the root node. And then there's a call, and this is going to be from 0 to line. So this is the def module, right? And then it goes down a level, and here's the identifier, which is def module is the call. And I'm just basing this based on what I know the contents are. Arguments to the call are rows, so 10 to 13. That's our module foo. Thanks for coming, Tuxified. Good to see you again. I'm glad you find this interesting still. Okay, and then there's and this is another node, so it's an alias. So in this case, foo being a module name, that's the syntax node there is alias. And then there's do block. Okay, so this is from the end of that line, column 14, to row 1, column 3. Right, because we don't have anything in there. We just do end. And then here's the do token. This is not a named token. I did learn what the difference between named and not named are. Named tokens are actual, either they have labels on them in the grammar, or they are rules themselves. But for a concrete, because a tree sitter gives you a concrete syntax tree, which we may in a future stream, or maybe today if we have time, we may want to look at, well, get me the named nodes versus all the nodes. And maybe that could be an option to pre-walk, or maybe it could be an option, or it could be a different call. We'll see. Anyway, so you can see here, do, the token do is a concrete node. And then we have the token end, and that's the end of our first parse tree. Okay, so then we edit it, and then we get the source is expanded to byte 30. And we have row 2, column 3. And then we have our comment. So I think this seems to work. In order for this to be a useful API, I think that you're really going to need the information up front. We've crafted it. We've handcrafted it here. I think this would be really hard to do correctly. If you weren't inside an editor that is tracking all this stuff. Okay, so this is our original node that was let's look at that. This was the call, right? Let's see if that, and maybe this can be part of our test, right? I think that's probably useful. So let's see. Let's say old mod node. Let's see, tree sitter.tree.prewalk. we're going to enum find, and this is going to take the node. And actually, we can do something like, what was it in the text here? Kind is call. Or kind ID is 175. Yeah, let's do kind is call. Right? And then we're going to comment this out, right? And then we say new mod node. And we're going to say basically this, but with the new tree. And then let's assert that old mod node dot ID equals the new mod node dot ID. You know, if this weren't a thing where I'm unsure about how we're using this API, I probably wouldn't write this particular assertion, because this is like, is tree sitter doing the right job type of test. But since we're going through so many layers here, and there's some uncertainty about the tree edits, whether those make sense, I want to get this. Yeah, okay, so it gave us different nodes. Gave us different node IDs. Which to me says maybe our edit is wrong here, as Sam suspected. So let's try Sam's suggestion here. Let's go 0, right? Because this was, you know, a 0 length change. Yeah, that's an interesting question. Let's try, before we do that, let's try that. That's a really good. So we need to put there comment, and then we need to figure out old end position is row 1, column 3. New one is row 2, except it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's what we saw when we were parsing that. Okay. Yeah, let's try that. That's a good way to validate our assumption about this being, you're trying to give. Although, does this start byte then need to be where the start of the edit, not the start of the buffer, the start of the document? If this were the case, so let's say we were editing at the end like this, wouldn't start byte be the same as old end byte? I think it would. Okay, so let's say the edit is in the middle. Would your old end byte not be the same as the start byte in that case as well? All right. Before we come back to that, let's try this and see what we get. Yeah, different nodes. My guess here is that tree sitter goes, you know, it accepts the edit and it goes and it gets the new text and it's like, Yeah, this doesn't look at all like the edit that you intended, so I'm just going to make a new tree. That's what I would guess. So, yeah, let's try making it just the span that changed. So the start byte would be the end of the previous one, right? And that start position would be the same as the old end position, right? Let's try that. Still fails, so they're still not reusing that. Maybe it's time to Google some things. Okay, just say tree sitter input edit, and see if we get any. So stuff I've already looked at. I don't know that this. It's about querying highlights, scope tests. Yeah, this is. I don't think this is what we want. Scoping arbitrary ranges. Nope. Okay. Maybe what if we looked at. Let's look at this. And look at this repository in here. If we can look at if they're using, that's just completion. See if they're using input edits at all. Nope. Not useful. Okay. Right. Fine. Use syntax highlighting. Don't care. Yeah, and you're trying to sell me on this goop, and what I want is actual detailed stuff. Okay, editors using tree size. So Atom, Visual Studio Code, NeoVim, Emacs. Yeah, the official documentation is not going to tell us what these things mean. We might be out of luck. And I might leave that test in there with a skip on it. And yeah, thank you, Sam. Sam said he's going to look at GitHub code search and see if it turns up anything. Right. Let's look at what the Emacs folks say for this. Built-in integration. Right. Don't care. Now, I do have Emacs open. I could add the tree sitter module, although I am using 29, which includes it. So let's see if we can maybe just go and look at this. And let's see here. No, slash doesn't do what I thought. Okay. Let's Tree sitter. Is there anything in here? No. Tree sit. Okay. Let's see if there's a tree edit function. Parser included ranges. Interesting. Let's just jump to that. Oh, it's in C source code. Fun. Ah, no, it expects me to have the C source code available. Brilliant. Well, is there a... Let's see if there's a Emacs fork on GitHub. There's Spacemacs. Here's a mirror. And let's search in here for tree sit. Okay, treesit.h, treesit.c. Let's see if they do anything interesting in here. We're doing some real spelunking. Go back to all symbols. Tree edit. Okay. So save the field. Assumes tree is not null. Start byte old and byte notice not be large and unit 30 max. Okay, so interestingly, they're just putting in dummy points. So you maybe don't even need to know what the row and column are. Maybe we can see, okay, so there's references to this. What are we doing in this function? Okay, so update each parser's tree after the user made an edit. This function does not parse the buffer and only updates the tree, so it should be very fast. Okay, so this is where they're calling edit. Fun. Implementation of a Lisp. Okay, so the buffer. Fine. Okay, so if the tree exists, recorded changes, a delete followed by an insert. Think of them as moving unchanged text back and forth. So affected start, old end, new end are zero-based offsets from the visible beginning. Clips value, okay, and subtracting. Okay, so the start offset is minimum visible end, max of visible beginning or start byte minus that. Okay. The narrowed region. Yeah, this looks like it's based on, I don't know where this new byte comes from. I mean, it's, you know, you've got all those as arguments. And I'm not sure what their visible beginning, visible end stuff is here, but they're calling this narrowed region will grow to accommodate the new text. This is correct behavior. Okay. Right, let's jump down here. Okay, I think this is inside the same function. No, okay, so sync visible region. Oh, I guess what they're doing here is they're only parsing the visible region of the editor. That's why this is... they're not parsing the whole document. Okay. So, um, okay. So if it's an insert at the beginning, they're passing, remember this is, can I expand that a little bit? No, apparently not. Um, they pass the tree, the start byte, the old end byte, and then the new end byte. So this does look like, based on this, Sam, if we're understanding this correctly, it does look like they're calling it with what part of the tree was edited, right? Um, okay, so if it's an insert at the end, I don't know what these what these calls are. I think they're macros. Anyway, um, so it takes the tree and then the region of the screen that's visible, right? And the start byte and the old end byte are the same, and then it's saying it's at the end there. Okay, and then a delete at the end. Okay, this time they're different. We've got the start byte and the new end byte are the same, but the old end byte is different for a delete at the end. It's really interesting to me that you can pass 0, 0 to dummy as the points on the positions. Okay, so at the very least for our example, we can say an insert at the end, the start byte and the old end byte should be the same. And then the new end byte should be the length of the buffer of the new buffer. So let's see if we can fix that. So this is actually what we have here. Yeah. Um, which should be correct. Now, I don't know that that necessarily means that it will give back the same IDs for some nodes. Um, let's do, rather than this, let's comment these out. We're going to do another IO inspect like we did before. But we're going to say and just print out the IDs. Label B4. Do they have? It's really interesting to me that they're only doing the visible range of the buffer because that's not how grammars work. Do they have something to do? Do they have to do something weirder? I don't know. I think that we would have to dig deeper into how Emacs represents the parse tree or the contents of the buffer. I could understand why, for performance reasons, you might want to only parse the visible area of the buffer, but you could come out with an invalid syntax tree. Yeah, it's a bit unconventional. And if you think back to some of the problems that Emacs had with performance in the past, aside from just being single threaded, some of it was that so they had this system. I don't know if they're still using it, but they had this system called font lock for syntax highlighting, um, and and if you had a really large buffer, it would just not syntax highlight. And I think that some of the compromises they made were, if possible, try to syntax highlight only areas that are visible, and then as you load more, as more of the pages of the document become visible, the screen fulls basically, then it would start to parse those and syntax highlight those. But yeah, let's see what the IDs are, because there aren't that many nodes, right? In either document, there aren't that many nodes. So let's see what they look like before and after, and see if any of them match. It's going to be hard to tell, to be honest. Um, but I expect the root nodes to be different, and then there'll be the comment node, and yeah, that looks close, but that's not quite right. Yeah, I don't see any shared there. So I think what we're gonna do is we're gonna move on. I'm gonna say skip. Um, First one on the second line has the same ID. Yes, it does. Interesting. Um, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we would expect. One node in difference. If I had to guess, Sam, I bet that's the do token. uh, but I'm not positive. No, or it might be the foo module name. Um, let's let's uh, let's map out more than one thing here. Let's say one dot. What was the field on there? Kind. Yep. And then we'll get that down here too, and we can see a little bit more there. Did I change the line number, or did I not print something out here? Did I leave the skip? I bet I left the skip in there. No, I commented it out. Oh, we're on line 60 now. It didn't run anything. Okay. Okay, so we had source, call, identifier, arguments, alias, and it's the alias that's the same. So it is that foo. Um, it's interesting to me that these other nodes don't share. Because that's very little sharing. Now, I mean, we can test that, right? Um, so so rather than call, let's say alias, because we know that that's not changed. Um, and then we can play around with maybe doing it at the beginning and at the end, and see if it's able to find those similarities. let's delete that. It is really interesting to me that that's the only thing that was shared, because there's no difference at the beginning of this. It's all at the end, which could mean that we're just not giving it the right kind of input edit. Yeah. Okay, so it does pass now. I'm going to put a note in here that says it feels really unpredictable what will and will not be shared between trees after edits. We really need to understand this input edit struct a lot better. And possibly have lowered expectations. Okay. So at the very least, and again, I'm not trying to here test from Elixir that tree sitter is doing the correct thing. What I'm trying to test here is, does our integration go all the way through? And are we getting something useful out of it? And I think that even though the sharing here is so minimal, I would expect, def module is a keyword. Do is a concrete syntax node. I would expect those things, like everything up to this, line return. I would expect everything in there to be shared, but it's not. Yeah, it's the "Are we holding it right?" test for sure. More up to the left, please. So I think this is fine. And what I would hope is that if this is a thing where let's say for based on the original use case, that we are supporting a language server here. Thank you, Sam. I do know about holding things. If we're supporting a language server here, I would expect that if it needs to use this API, I don't know that it does, but if it does, then the editor is going to send, here's the region of the document that was edited. And then it's on the onus of the language server writer to go, okay, I'm going to turn that into the correct input edit. And so I'm going to have to figure that out. And that's not a thing that I feel like I can determine right now. And I appreciate your help there, Sam, at trying things. But also we don't really know if we're using this correctly. I think it was pretty clear that based on the Emacs source, forgetting the visible or invisible bits, that when an edit is at the end, the start byte and the old end byte are the same, and then the new end byte is the length of the updated buffer. So I think that was fairly clear. Obviously, they are not caring about the start position, old position, and so forth. One thing we might do is provide defaults for these in our struct definition, and just set them to 0, and then you don't have to specify them, because that's what the Emacs code was doing. All right, so let's look back here. So I think let's make a commit. We'll call tree edits done, and we'll move on with our lives. We will move on with our lives. The other thing we could potentially do, rather than go over here, rather than having a separate function for reparse, we have a clause of parse that takes an optional argument. We could potentially do that. I don't know how I feel about that, because we would need to look at whether it's nil, and if it's nil, then call parse or call reparse. Maybe that's something. Let's put that in here. Let's do another subtask for this. Say, but it's not done. Unify parse and reparse, because maybe they don't need to be separate APIs. Maybe it can just be, well, you can choose to pass the tree or not. Yeah. Oh, that's a good point, Sam. He says, I imagine the Emacs code isn't dealing with positions because it'll translate back from the visible byte offset to the position somewhere else and not care if tree sitter gets that right or wrong. That's probably very true. And maybe it simply ignores the positions that tree sitter returns from its functions. Okay. So I think one thing we could potentially do, let's get this commit done, and then we'll maybe do a little bit of cleanup. I maybe won't get to multi-language today. I think what might be useful for lack of a better thing is to refactor this, and maybe we can get rid of some of these compilation problems around, pattern matching. I think if they're separate compilation units, it gets separate modules, it gets better, but we'll see. Okay, let's make a commit. Woo! Lots to update. Let's look at what the diff is. Okay, so we added the reparse function, we added the tree edit, we've got the input edit struct, and added the NIF stuff. We moved things to the document module. Good night, Sam. Thank you for joining. Yep. Okay. Okay. Excuse my scrolling really fast. Probably doesn't look very good on the stream. I'm just trying to make sure that the changes in there make sense and that I account for everything. Okay. Support tree edits, and move the node point range structs into document.rs. Add input edit structs top to bottom. Add tree edit API, and add parser reparse reusing old tree. And yeah, so I think now is a good time to start to make more stuff here. And maybe we'll try to do some parallel to here. Although I think tree is going to have to be in its own file if we want to pattern match on it rather than using these struct calls. So let's go ahead and let's make some cleanup here. Let's make a new file, document. Ooh, how do I type? Document.ex. Okay. And we're going to do like we did in the other, in the Rust code, we're going to put those just basic document structs in there. Okay, and then we need to make tree its own file. And we will just move this wholesale. And then we maybe will be able to see if that can be changed. And then let's make parser. Oops. Its own file. Okay. And then we just have language, and that kind of means we can delete this file. I don't know if there's going to be anything in here, but let's just, you know, honestly, it's so small. We'll leave it in here. Let's make sure we can compile still. Okay. And now let's try to remove those, like this stuff. Let's try to turn it into a syntactical structure rather than a macro call. Waiting for the shoe to drop. So far, so good. Okay. So let's do this. And then let's pattern match here. Yeah, this is a thing. I don't know that it's an explicit limitation of the compiler, but yeah, let's actually not do this. Let's pattern match it out, and then we can just do there. Yep. Okay. That's good. And now we can do the same over here for input edit, because we also had that problem where it was in the same file. And that's just, we don't need to destructure anything there. We just need to pattern match it. Oh. Bogus. Here, let's see if we can compile. Yeah, it's fine. Probably just need to restart the language server. It still thinks it's a problem. That's interesting, because when you compile, it has no problems. Did I not save something? No, everything's saved. Okay, now it's fine. The language server took a minute to catch up. Okay, we can stop now. I'm happy to take questions or comments. I think we got pretty far. Let's make a commit for this refactor. I'm just going to keep a one-liner. Split struct modules into separate files to prevent compilation errors. Okay. Yeah. Let's push and then call it. Thank you all for coming today. And I know Sam has already dropped, but thank you, Sam, for all your feedback. And we're making really good progress. I'm proud of this. You know, I think I had some irrational exuberance about it when we first started. That is passing a little bit. But maybe we can get to next time multi-language documents. We'll fix this. This would probably be a 10 or 15 minute refactor, so that the NIF functions can take an optional old tree, and then it'll be more like the tree sitter API anyway. And we'll put we'll do some refactoring on the Elixir side to give optional arguments to parse potentially, and then if you don't pass the tree, then it'll just assume you want a new one, and you're not doing an edit. And then we can look at multi-language documents. I think we have an interesting setup here in that the parser has the language in it. And I don't know if you remember at the beginning of the stream, I was looking at that example for multi-language parsing. When you say you could say set language, we could take advantage of this and let you reuse the parser for a different language, which would be pretty cool. So yeah, I think that's where we'll call it. Thank you all for coming, and we will see you next time, I hope. Have a good weekend.